According to the Bureau of Labor Statistics, falls are the #3 cause of death in the workplace. Half of these falls occur in the construction industry, where falls are the #1 cause of death. In addition to the loss in terms of human suffering, the financial loss to the business community is staggering due to increased costs for insurance premiums, workers' compensation, and product liability costs.
But these losses can be minimized through the implementation of a comprehensive fall protection program. In this video, you'll learn the proper way to develop such a program in your company. At Delo's Fall Protection, we believe that a comprehensive fall protection program includes these key components. Identification of all predictable fall hazards through a site survey conducted by a qualified person. A written fall protection plan that details the fall prevention and protection methods to be used for each hazard. The proper fall prevention and protection equipment for each hazard, and rescue plans. A thorough understanding by all workers of applicable standards and regulations. Proper selection of fall protection equipment, and a comprehensive training program for all workers. In order to be effective, all parts of the program must be in place and working together.
A well-conceived fall protection program begins with the identification of all fall hazards in the workplace. As a general rule, anytime a worker is at a height of more than 4 feet, a fall hazard exists.
When a hazard is found, 2 options are acceptable.
First, the hazard can be prevented by eliminating it. Prevention methods can include engineering solutions such as guardrails or simply avoidance of the hazard. This is the ideal approach, although it may be impractical. Second, protection can be provided through the use of personal fall arrest systems. Once all hazards have been identified, a written plan outlining how to deal with each hazard should be developed. If the hazard can be prevented by eliminating the exposures through engineering methods or new work procedures, these procedures should be specified. Where prevention is impossible, the plan should state what equipment is to be used, how it is to be used, and who is responsible for supervision and training. The plan must address these essential elements and be clearly understood by all concerned. Safety regulations governing your particular work environment are set forth in publications offered by OSHA and ANSI in the U.S. and in Canada by CSA and the provincial governments.
You should be sure to obtain copies of all applicable regulations.
All workers must be trained in the proper use of fall protection equipment before attempting to use any fall protection products. Employees must also receive instruction on inspection and maintenance procedures, as well as the proper way to wear fall protection equipment. Rescue plans should be developed and rehearsed in such a way that each member of the rescue team understands his or her responsibilities and has developed the skills necessary to perform the individual tasks required. It is up to the employer to select the safety equipment which is appropriate for a particular situation.
Fall protection can be divided into 4 functional categories, which are identified by symbols. The first category is the personal fall arrest system. The system is intended to come into use only in the event of a fall.
A personal fall arrest system consists of a full-body harness, a connecting device such as a shock-absorbing lanyard, an anchorage connector such as a cross-arm strap, and an anchor point capable of supporting 5,000 pounds per employee attached.
The second category is the personal positioning system, which holds a worker in place while allowing a hands-free work environment.
Many types of positioning systems are available, but the most common system consists of a full-body harness with side or front D-rings, a positioning device such as a rebar chain assembly, and an attachment point. Depending on the work being performed, regulations may require a fall arrest system to be used in conjunction with a personal positioning system.
The third category is the personal suspension system. It is used in such activities as building maintenance, painting, or window washing. A personal suspension system is designed to lower and support the worker in a hands-free configuration.
This system generally consists of a positioning chair, a work line, and an attachment point. Most regulations require that a fall arrest system be used in conjunction with a personal suspension system.
The final category of fall protection products is retrieval equipment. This is generally used in applications where workers must enter tanks, manholes, and other confined spaces.
A retrieval system consists of a full-body harness, a retrieval unit, and an attachment point such as a tripod. The most basic item of fall protection equipment is the full-body harness. A full-body harness distributes fall forces throughout the body, thus reducing the chance of injury. Body belts are not recommended for fall arrest. In addition, most regulations governing fall protection prohibit the use of belts. In this drop test, a dummy is dropped into a body belt. Note how the fall forces were concentrated on the abdomen. Such forces concentrated on the abdomen could cause serious internal injuries. In addition to optimum force distribution, a full-body harness keeps the worker suspended upright while awaiting rescue. This is due to the sliding D-ring, which moves to the nape of the neck once a fall occurs. This allows the worker to remain as comfortable as possible until a rescue team arrives. Before using any fall protection equipment, the worker must carefully read and understand all instructions and warnings. In order to ensure proper protection, the full body harness must be worn properly. First, hold the harness by the back D-ring and shake to allow any tangled straps to fall into place. If chest or leg straps are buckled, unbuckle them at this time. If the harness has a waist belt, unbuckle it also. Slip the straps over the shoulders so the back D-ring is located in the middle of the back between the shoulder blades. Pull the end of one leg strap between the legs and secure to the opposite end. Repeat this step with the other leg. Connect the waist strap if the harness has one. This should be tight but not binding. Fasten the chest strap and position in the mid-chest area. Tighten to keep shoulder straps taut. After all the straps have been buckled, tighten all buckles so that the harness is snug but allows a full range of movement. Secure any excess webbing by tucking it under loop keepers. To remove the harness, reverse these steps. Another vital element in the fall protection system is the connecting device. The connecting device is a flexible line used to connect the body harness to the anchorage connector. When attaching the connecting device to the harness, attach to the back D-ring located between the shoulder blades. If other D-rings are present, they're for positioning or retrieval only, not for fall arrest. The two most common connecting devices are lanyards and retractables. Lanyards come in a variety of types, such as steel, rope, and webbing. While all of these will stop a fall, OSHA and provincial regulations require that the maximum arresting force when using a full-body harness be less than 1,800 pounds. This is extremely difficult to achieve using a lanyard that does not have a shock absorber. Therefore, as a general rule, when using a lanyard, it is recommended to use the shock-absorbing type. This testing apparatus is used to measure the energy generated by a fall. Let's look at the force generated by a 220-pound dummy falling 6 feet. Here the drop test is performed on a steel lanyard. Note the head snap and bouncing of the dummy. Forces are well over 3,000 pounds. Now, a rope lanyard. And a web lanyard, both with forces over 2,000 pounds. In each case, the extreme forces generated caused head snap and bouncing of the dummy. Finally, the test is performed with a shock-absorbing lanyard. Note the smoother and more controlled deceleration. Forces are under 900 pounds. The second category of connecting devices is retractables, also known as fall limiters. Retractables consist of a length of webbing or cable wound on a lightly tensioned spring-loaded drum. As the worker moves away from the anchor point, the retractable pays out the webbing or cable. As the worker moves back, the unit retracts the excess material. Should a fall occur, an internal braking system engages and arrests the fall while keeping the forces at about 900 pounds. Retractables are beneficial because they minimize the free fall distance. They are also very convenient whenever maximum worker mobility is needed. Another type of connecting device is the vertical lifeline. A vertical lifeline is made of rope or cable. Vertical lifelines are used in combination with a rope or cable grab. The worker slides the grab up or down the lifeline as the worker moves. The anchorage connector is the link between the connecting device and the anchor point. Anchorage connectors are available in a variety of configurations for connecting to large beams, small beams or scaffolds, rooftops, structural steel, and more. Some lanyards now have built-in anchorage connectors. This lanyard has a special snap hook and high-strength webbing that are designed expressly for use as an anchorage connector. A worker wraps it around a structural steel member and attaches it back onto itself. All tie-back lanyards must have a snap hook designed for such use. Never use a regular lanyard or a lanyard with a regular snap hook for tying back. The forces generated in a fall can damage or break a regular snap hook used in a tie-back situation. Only use tie-back lanyards with a special snap hook designed to withstand the extreme fall forces. When selecting an anchor point, remember, it must be capable of supporting 5,000 pounds per worker and be compatible with your anchorage connector. Attach in a manner which will limit the free fall to the shortest possible distance, never more than 6 feet when using a lanyard, unless you are using equipment designed expressly for free falls over 6 feet. Attach in a way that avoids a dangerous swing fall. Use your anchorage connector to attach to the anchor point and attach your connecting device to the anchorage connector. Another important element in preparing a personal fall arrest system is calculating your available fall clearance. This is critical so that a lower level is not struck in the event of a fall. As shown in this diagram, a worker who is 6 feet tall using a 6-foot shock-absorbing lanyard requires 18.5 feet of fall clearance. In this case, there needs to be at least 18.5 feet between the point where the connecting device attaches to the anchorage connector and the next lower level or obstruction below the worker. In calculating the fall clearance requirement, consider the following elements: the original length of the connecting device, the maximum elongation of the shock absorber, or if using a retractable, the stopping distance of the braking system, the height of the worker, a safety factor of at least 3 feet. Special consideration needs to be taken when using long vertical lifelines. Rope can stretch up to 15%, and this stretch needs to be factored into the fall clearance requirement. Because situations vary, the required clearance must be considered in every application.
Full-body harnesses are designed for rugged use. To maintain their service life and high performance, they should be visually inspected before each use and thoroughly inspected by a competent person at regular intervals. The intervals and record-keeping methods of the inspection should be part of your fall protection program.
To begin inspection, grasp the harness webbing with your hands 6 to 8 inches apart. Bend the webbing in an inverted U as shown. The surface tension resulting makes damaged fibers or cuts easier to see. Follow this procedure the entire length of the webbing, inspecting both sides of each strap. Watch for frayed edges, broken fibers, pulled stitches, cuts, burns, and chemical damage. Check the D-rings and associated metal parts for damaging corrosion, distortion, cracks, breaks, and rough or sharp edges. Buckles should be given special attention. Note any unusual wear, frayed or cut webbing fibers, or buckle distortion. Mating and friction buckles should not be bent or distorted. Tongue buckles receive heavy wear from repeated buckling and unbuckling. Inspect for loose, broken, or distorted grommets. Straps should not have additional punched holes. The tongue should be free of distortion, should overlap the buckle frame, and should move freely. The roller should turn freely on the frame. Inspect snap hooks for distortion, cracks, and corrosion. The keeper must seat onto the nose without obstruction. The keeper spring should exert sufficient force to close the keeper firmly. The snap hook locking mechanism should keep the hook skate securely locked to protect against accidental disengagement. The thimble of a rope lanyard must be firmly seated in the eye of the splice and should have no loose or cut strands. Look for distorted or doubled over thimbles in the eye of the splice. Steel cable on a lanyard or retractable should be rotated while inspected for worn or broken strands. Wear gloves and use a cloth to run over the length of the cable to check for broken strands. The entire length of webbing on a lanyard or retractable should be bent over a pipe to inspect for cuts, breaks, or any other signs of damage. Rotate a rope lanyard while inspecting end to end. Look for any signs of cuts, fuzzy or broken fibers, or reduced diameter. The outer portion of a shock-absorbing pack should be inspected for tears or burn holes. Stitching at the points where the pack is attached to D-rings or lanyards should be inspected for damage. Lanyards with a shock-absorbing inner core should be examined similar to a web lanyard. However, also look for signs of deployment. This lanyard has a warning flag that indicates whether it has seen a fall. If the flag has been activated, is missing, or other signs of deployment are apparent, remove the lanyard from service. Retractables should be inspected before each use according to the manufacturer's instructions. Usually this includes checking the braking system by applying a sharp pull on the cable or webbing, and checking the retraction by pulling out several feet of material and letting it retract under light tension.
As a review, let's explore the do's and don'ts of fall protection.
Fall protection equipment should be used only by those individuals who have received training from a competent person. Understand all applicable OSHA, ANSI, and CSA regulations regarding fall protection before using equipment. Employers should provide for prompt rescue should a fall occur. Rescue procedures should be reviewed as part of the company's regular safety training program. Read all instructions and warnings contained on and in the product packaging before using any fall protection equipment. All fall protection equipment should be carefully inspected before each use. If any damage is detected, the equipment should be removed from service. Attach in a manner which will limit a free fall to the shortest possible distance, always less than 6 feet, and attach so as to avoid a swing fall. And make sure there is enough clearance below the worker so a lower level will not be contacted should a fall occur. Use only the back D-ring on a full-body harness for fall arrest. Other D-rings are for positioning or retrieval only. Every year, about 100,000 people are injured or die from fall-related injuries. The good news is that the equipment and know-how exists that can prevent these tragedies from occurring. Fall prevention in the workplace begins with a commitment to safety. Both management and employees must be thoroughly committed for a fall protection plan to be effective. Take the time to ensure your workplace is a safe place. Be committed to safety. Develop a fall protection plan. Provide proper training. Follow standards and regulations, and your workplace can be safe from the preventable tragedy of falls.